Traditionally, the seaweed industry in Ireland was based on naturally harvesting wild seaweed and drying it. However, over the last decade, BIM have developed a programme of works which has looked at the possibility and the potential for farming seaweed in Ireland. Starting in 2004 at the Daithí Ó Murchú Marine Research Station, BIM set up a pilot-scale hatchery, and in this hatchery we developed techniques for growing all species, many species of kelp. The main species that we started with was Atlantic wakame, and since then we have started from our early days producing just over 1,000 metres of seeded string to current production of a capacity for approximately 20,000 metres string. Okay, so this is a diagram of the life cycle of Alaria esculente or Atlantic wakame, and down here we have the sporophylls. This is where the reproductive material is contained. So at this time of the year, October, November and into December, these sporophylls, the sori, the reproductive areas, develop in the sporophyll leaflets, and we end up with darkened patches in the actual leaflet, and this is where we have the actual spores. So in the wild, at this time of the year, triggered by light and temperature, these spores are released. Mature sporophylls are available in the wild from approximately early October to mid-December. These sporophylls are collected on the shore at low spring tide and brought into the lab, where we select individual leaflets for final washing and preparation. It takes approximately 3 to 4 hours to prep the individual leaflets to ensure that there are no epiphytes, or to try and remove any surface contaminants that might be present. These sporophylls are then placed in a flask overnight in the dark, partially dehydrate. Next morning, 24 hours later, we add sterile seawater, and this instantly causes spore release. After approximately 1 hour, we have spores floating in the 1 litre of sterile seawater. And as you can see now, there's quite a bit of colour in the water, so we've had a good spore release. Now we need to transfer the spore culture into our flask, which contains sterile seawater. And nutrients. So we just want to filter off the leaflets so that they don't enter the culture vessel. Simply pour it through a 30 micron filter. We just label our flask and put it in the cold room. The culture flasks are maintained in a temperature control room at 14 degrees centigrade and 24-hour light. This way we inhibit fertilisation and allow the culture to grow vegetatively. This occurs in this cold room for approximately 6 weeks. As the culture grows, it darkens in colour, starting at a very pale yellow or straw colour up to a very dark brown. In order to maintain these cultures, we need to renew the culture medium every week. To induce fertilisation in the culture, we need to drop the temperature of the culture room from 14 degrees gradually down to 10 degrees. We also adjust the light parameters to have 12 hours light and 12 hours dark. Under these conditions, over the next 8 to 10 days, the culture will eventually fertilise. By day 10, we are ready to spray the culture onto culture collectors. These collectors are PVC tubes covered in polyamide string. We simply spray the culture onto the collectors using compressed air to ensure an even distribution of culture all over the culture string. The collectors are then placed in the air to drip dry literally for approximately 8 minutes. We then move the collectors into a 500 litre bin at 10 degrees centigrade. The water in this bin has been filtered to 1 micron and it has passed through a UV filter. Right, sea sites need to be carefully selected. The first thing is that Alaria esculenta requires full salinity. Secondly, we need to ensure that the long lines are positioned well in the sea. That requires at least 1 tonne blocks at each end of the long lines. Normally long lines are 1 to 200 metres in length, and the long line must be positioned approximately half a metre to 1 metre below the sea surface. Any deeper than this and the light penetration will be poor. So when the collectors are ready to go to sea, they are transported to the sea site wrapped in damp cloth in boxes. It is imperative that the deployment to sea occurs on a calm day. It is really difficult to do this operation correctly in bad weather conditions. The collectors are unwound onto the long line without any handling of the actual string. Buoys are inserted at approximately 10 metre intervals. If this is done correctly during this stage of the operation, we will ensure an excellent result. Bad deployment invariably results in tangled lines, loss of buoys, movement of anchors. So it really is, this is the really important part of it, because after this we have to do nothing but sit back and wait for the seaweed to grow. Normally, for the first month or two after deployment to sea, there is very little obvious algal growth, but very quickly after that the growth pattern is very fast, and after approximately 5 months at sea we generally reach a biomass of a minimum of 7 kilos per linear metre. In fact, we have exceeded this level many times at our sites on the west and the southwest of Ireland. Our highest biomass yield per linear metre of string was recorded in Bantry Bay, where we achieved 20 kilos per linear metre. So, over the last 10 years here in West Cork, we have fine-tuned our cultivation techniques and we have successfully produced 3 different species of kelp. We are delighted to see various companies in the southwest developing seafood products. The outlook and the prospect for the future is extremely promising.